Welcome back. We are in applied physics subject, quantum mechanics chapter. Lecture 2 is Planck's law and properties of photons. What is this Planck's law? Max Planck is the scientist who introduced quantum theory of radiation to explain the distribution of energy in the spectrum of blackbody radiation in the year 1900. So especially the frequency distribution of thermal radiation will be taken into the consideration. And you know very well, so Planck introduced his quantum theory only to explain the distribution of energy in the spectrum of blackbody radiation, which is coming out in the form of continuous manner. He assumed that the atoms of the walls of the blackbody behave like small harmonic oscillators, each having a characteristic frequency of vibration. And the main assumptions in the Planck's law are an oscillating atom can absorb or emit in the discrete units. The indivisible discrete unit of energy is h nu, and it is called as energy quantum. And mathematically, it will be represented as E equals to h nu. Here E is the energy, and h is the Planck's constant, and nu is the frequency of the radiation. So here, the emission or absorption of energy will be takes place in the form of discrete units of energy. Here we are not having continuous emission or absorption of energy. And the second main assumption is the energy of the oscillator is quantized. What is the meaning of this quantization? We cannot further subdivide the minimum amount of energy which is represented in the form of quantums represented E is equals to h nu. It can have only certain discrete values of energy. So En equals to nh nu, where n is an integer which starts from 1 onwards. That means zero energy is, if you substitute n as 0, we will get E as 0. So zero amount of energy is not applicable according to the Planck's law. This hypothesis is mainly focused on radiant energy which is absorbed or emitted in a discontinuous manner. And it is in the form of quanta is known as Planck's quantum hypothesis. You can able to see in this diagram. So the various energy levels are allowed in case of any system. So those are named as E1, E2, E3, E4. And E1 is having certain energy, and E2 is having little bit excess amount of energy, but which is not continuous. For example, E1 is the specific energy level which is having 1 electron volts of energy, suppose, and E2 will be the energy level which is having either 4 electron volts or 5 electron volts. That means the energy difference between E2 and E1 is defined by a small amount, but in the discontinuous manner. And in this diagram, we can able to see what is the difference between continuous energy distribution and discontinuous energy distribution according to the Planck's quantum theory. These are all the quantized energy levels, quantized energy levels. The energy levels of all atoms are quantized. In the diagram A, we can able to see a ramp which varies continuous energy distribution like an elevated path. So according to the classical mechanics, so the energy varies in a continuous manner. But that is not true in case of quantum mechanics as well as in case of Planck's quantum theory. In the figure B, we can able to see a flight of stairs. Yellows only in certain elevations. The elevations are quantized. That means the lower energy level, E1, next one is E2, next one is E3. That means it does not allow any continuous elevation of energy. Therefore, energy levels are quantized and those are in discontinuous manner or in the form of discrete energy levels. And if we consider the properties of photons, these are the main properties of photons. Energy of the photon E is equals to h nu. Already mentioned is the energy and h is the Planck's constant. And you know the value of Planck's constant 6.64 into 10 power minus 34 joule second. And u is the frequency. And the velocity. Velocity of the photons. Photons are traveled with velocity of light, which is usually represented with the c. And the value of velocity of light is 3 into 10 power 8 meters per second. Then the third property is rest mass. Photons can never be at rest. Usually those are not at rest. Rest mass means whenever the particle or object which is at rest, we can able to find out its mass, then it will be called as rest mass. Usually the particle or object which is at rest, then we can able to calculate this rest mass. Usually photon, which is a very, very small particle, they are continuously moving. That's why they are not at rest. Therefore, rest mass is not applicable for the photon. And relativistic mass, E is equals to mc square or m equals to E by c square. So relativistic mass means with corresponding to the velocity, we can able to measure the value of mass, that is called as relativistic mass. Then linear momentum. What is this momentum? Moment is nothing but a product of mass and velocity. Here linear momentum, which is represented with p, is a function of h by lambda. Again, h is the Planck's constant and lambda is the wavelength. And the next property is electric charge. Photons are electrically neutral and cannot be influenced by either electric or magnetic field. And they cannot ionize the matter. That means if you encounter the photon with any matter, and they will be showing neutral effect. Thank you for listening.